Hello friends, welcome back to the bench. Thank you very much for joining me. Our patient is this beautiful ASRock Z170 Extreme 7 Plus series, which has very nice outputs. You can see PS2, so it's a this weird gaming board. We got 3 NVMEs and 4 PCI Express boards. Pretty big coils. It is only 1151 socket, right? In the last video I kept referring to it as 1151, but it was actually 1200. That's why 1200 sockets I support much better CPUs than 1151. So this is a little older board and it will not support like massive CPUs. But still we have plenty of coils on CPU core. Very nice electrolytic caps, kind of gold looking, right? Which sucks because I prefer solid state, because then I don't have to worry about covering them or them exploding or all kinds of stuff like that. The reason I want to get this board done, because this board belongs to me. I bought it on eBay, and it has like 4 pins completely broken off. So the replacement is the only solution here. And I want to use this board for GPU testing or some different kind of testing. And the problem with the board I have right now is that it has only one PCI Express and no NVMe, no ability to connect SSDs to it. So I can test the GPU, but only go to BIOS, and that's pretty much it. But to properly test the GPU, and you need to log into the system and maybe run some benchmarks and that kind of stuff. So we need a board like this. Now, primarily what I'm interested in over here is testing the new feature on Rework Pro 1.1. That's a little sneak peek that we're gonna do today, which allows you to calibrate the thermocouple by fixed offset. And I'll show you guys that in just a second. But first we need to disassemble the board, clean it and prep it for the socket replacement, and let's do that and we'll be back in a minute. Alrighty, so our board is prepped. Now let's go to, or maybe before we do, let's consider this. We have 2 thermocouples, right? One in the back, and this one will be connecting here. All right, let's put it where it belongs, there. So now one thermocouple is showing 27 degrees, the other one 17. Let's connect in the Rework to observe that. Okay, we got 17, but there's about 27 degrees Celsius in the shop. So we're trailing behind roughly 10 degrees. However, it's important to remember that a thermocouple will not have a completely linear characteristic when it comes to reacting to temperature. So right now at this temperature it's trailing behind by 10 degrees. But when we get to 200 degrees it might be trailing behind 2 degrees or 5 degrees. So we need to estimate an average. So let's disconnect, change the zone A calibration by, say, 8 degrees. You can do 8 degrees. If it's showing too high, you can do -8 degrees or whatever number. Then connect. And now, and then now application is gonna crash. Okay, that was a quick bug. So let's do 8. We're trailing behind by 10. But I'm gonna start with 8, and now as you can see we're reading 25 degrees despite the machine saying that it's 17, but the other thermocouple is saying it's 27. So we're gonna try with 8 and we'll go from there. I wouldn't trust it too much, especially since there's a fan blowing from the top. But roughly those 2 thermocouples should show the same temperature. So now we have the ability to adjust that in the software. Alright, let's start preheating and let's get some socket replaced. Alrighty, now as it's cooling down, let's do a quick retrospective. I don't have the microscope set up and all that, I just want to finish this video. So we're not going to be looking at it and we're not going to be testing it. Why are we not going to be testing it? Now, as you saw, the difference between this thermocouple and the one in the back was at times as high as 60 degrees. Oh, that it started. So as I was removing, right after or right before I removed the socket, I heard the board crackling. Now, not in the way that sometimes boards popcorn, where they have too much humidity inside, and once you heat it up, they start popcorning. It wasn't this kind of, I mean, it is possible that maybe if I dried the board, it would have a better effect. But it seemed to me that it was just plainly overheated. And here's the mistake I made. When I introduced the thermocouple calibration, I only applied it to the reading temperature. So you can see on the graph how we have like this major overshot, right? The set point is way lower than the temperature, because the temperature the software reads is increased by that calibration factor that we added. But when we send the set point to the machine, it should be lowered by that amount, and I forgot about that, or actually I didn't even think about that. So we were setting the temperature too high. Now the socket didn't melt, right? The original socket. So you would think that it has not been overheated, right? There's no signs of melting, not even a little bit on the surface. It's a perfectly clean socket. So have we overheated it? Or the board had too much moisture inside. Maybe we should have actually typically I leave the boards for 2 cycles for preheating, and that also acts as a dryer, right? So maybe that was the problem. Maybe it's just the unfortunate board. Maybe it was overheated before, maybe it had the socket replaced before, who knows. So maybe this had nothing to do with our temperature, because the maximum temperature we observed, you can double check me on that because I don't remember, but I think it was roughly 260, 257, 258, something like that. So that is the dangerous level where the socket is gonna start melting. But we know this wasn't the actual temperature, otherwise this socket would show some signs of melting on the surface. Not completely melting, but signs of oxidation on the surface, right? We don't see that, so I'm leaning towards this board either needing to be dried to avoid this bubbling. Surprisingly, I don't see this bubble anymore. There was a big bubble where the thermocouple is right now, and I don't see that bubble anymore. It was here, right? And I don't seem to see it anymore. But in a very unfortunate place, because we have the memory rails here. So in either case, this is a failure, right? Even if the board, there's a chance this board will work, but in any case, this is definitely a failure. Now the socket is soldered on, it is holding, right? Here's the second thermocouple, and I could hear it. It was very loud crackling sounds from the board. I've never heard that before. This is the first board that does that, and the temperature didn't grow as much. As you can see, at no point we had 100% on the heater. So it's not like the heater was reading or the thermocouple was reading way too low temperature. But since we introduced a calibration factor, we must include that factor in the set point. That was the whole problem. So as soon as I'll throw this board on the pile of boards that might work, might not, probably for parts, I will get to the software and update that. Also, I found a bug. That was the bug that that caused the software to crash when we first started it. And it looks like this bug is in version 109. So I will see if I can issue a bug fix for that, but it's not a big issue. You just, when you start the program, you connect, do not disconnect and connect again, because then the software will crash if you hit disconnect and connect again. So, and if it does, then just, restart the program and then connect, and it, everything works fine. It just minor bug when disconnecting and reconnecting to the machine. It was one-liner. So I'll see. Maybe I'll issue a bug fix for that, but you can work around it. So it's not a crucial bug. But that is our little Saturday failure. We always appreciate failures because we always learn a lot from them. Alrighty, let's, what do we have, like 50-60 degrees on the board. Let's remove the thermocouple, number 1, then this one's saying 72. Fine, we're still in that calibration issue. We're still having the calibration issue, but we're getting close. We're getting close to getting this machine to actually perform like a professional machine. With every update to Rework Pro and every update to the machine and every board that I work for on, we're getting closer to turning IR6500 Rework Station into a professional tool, which by default it is not. Alrighty, thank you fellas very much for watching. I do appreciate you. I hope you found this interesting and you learned something from my little failure here. And I shall see you guys in the next one.